right, looking at part C of our chapter 2 review on limits. This is the section on continuity, and we are starting by using the definition of continuity to determine whether functions are continuous. And you do need to know that the definition of continuity is that a function is continuous when the limit as x approaches c of f of x is equal to f of c. And so this one, because my function is different on the left and right side of my point in question, x equals 3, then I will need to actually find the limit as x approaches 3 from the left, and I will need to find the limit as x approaches 3 from the right, and I will compare those answers and see if they are the same. So the left side, I'm using the equation 2x plus 1. 2 times 3 is 6, plus 1 is 7. The right side, I'm using the equation x squared minus 2. 3 squared is 9, minus 2 is also 7. So now I know that the limit as x approaches 3 of f of x does equal 7. That does not guarantee continuity. Right now, all we know is that as I approach 3, my left and my right are going towards 7. Whoops. So my left's going here, my right's going there, but we could still have a removable discontinuity and the limit exists. Showing the limit exists is not enough. Now I need to find the actual value of f of 3, and f of 3 is when x is equal to 3, and that happens up here on the top equation. So now I'm going to plug 3 into that. 2 times 3 plus 1 is 7. And by doing that, I now know that the ordered pair 3, 7 is part of this function, and that ordered pair fills in that potential hole left by the limit. And since the limit as x approaches 3 of f of x does equal f of 3, the function is continuous. I like to kill it dead and say they all equal 7, therefore f is continuous. Is continuous at x equals 3. Alright, so let's look at number 17. Same situation. My left side of the point in question and my right side are represented by different equations, so I'm going to have to find the limit as x approaches 2 from the left, and I'm going to have to find the limit as x approaches 2 from the right. Left side is represented by the equation x squared plus 1. 2 squared plus 1 is 5. Right side is the equation x plus 3. 2 plus 3 is 5. That's not a 5. Now is 5. And that means that I now know my limit as x approaches 2 of f of x is actually equal to 5. Now that's not enough to show continuity. All that means is that at 2, my left and right are going towards 5, but we could still have a hole there. We need to see if we can fill in that hole with the value of f of 2. So now I've got to find f of 2, and f of 2 means look exactly when x is equal to 2, and that's this middle piece. And when x is equal to 2, my function value is 7, which means that the ordered pair 2, 7 is where I'm going to plot the point. And if I plot that point, you can see that we are not continuous. We have a removable discontinuity. And the reason is because the limit as x approaches 2 of f of x does exist, but it is not equal to f of 2. Therefore, removable discontinuity. There we go. I think that's the last one on this part. Yep.